All right, I've been instructed to use the mic. At Mach 30, we believe that the key to open source hardware for everyone is high-quality open source engineering tools. Without tools like this, participating in advanced open source hardware projects could cost participants tens to hundreds of thousands of dollars, or if you want to do chip design, apparently millions. And while there is certainly a growing body of open source electrical engineering tools, things like CAD and the like, fields including CAD, computer-aided drafting and design, and engineering documentation lack sufficient open source tools. At Mach 30, we live by this belief that using all open source engineering tools for our open source hardware projects is essential. And we do this on all of our projects, even when those tools don't yet exist. Did I not advance the slide correctly? No, that was slide was supposed to be blank, honest. There's a method to the madness. It's okay, it's all good. Looking out for me. All right, for those of you that don't know who Mach 30 is, we're a US-based nonprofit dedicated to hastening the advancement of humanity into a spacefaring civilization, primarily by developing open source hardware for spaceflight. Yeah, open source rockets. And I am Jay Simmons. I'm the founder and president of Mach 30. I hold a PhD in space systems engineering, aka rocket science. And one of my roles at Mach 30 is to run our open source initiatives currently. So how exactly do we manage to live by that creed that I opened the presentation with when we find that we don't have the open source engineering tools that we need? Well, whenever possible, we find promising projects to contribute our time to improve them, to bring them up to the level we need. Failing that, we will break down and develop our own tools, open source, of course. Whenever we contribute to or develop new tools, that work is tied to specific open source hardware projects to ensure that the engineering tools have well understood and need-driven requirements. We don't want to just go off wandering, doing things off project scope just because it might be cool later. So we want to focus on what we need today. And then finally, we make sure that we apply these in-development open source software tools to those projects that drove the needs so that we can verify that we are actually developing the tools that are needed. All right, Rocket Science 101 in like 2 seconds. This is the architecture diagram, it's a block diagram for the simplest kind of rocket engine you can build. It's called a cold gas thruster. Cold gas thrusters yield their propulsive thrust simply by the energy stored in a compressed gas. There's no combustion, none of that. It's just put high pressure gas in a propellant tank and bleed it off. And that energy gives us thrust. Not a lot, but enough for some purposes. Mach 30 is currently designing its own cold gas thruster called the Yavin thruster. And Yavin is actually ideally suited to driving the development of engineering tools. Because, one, it relies on engineering analysis across multiple disciplines, rocket propulsion, structural analysis, things like that. And these engineering analyses need to drive parametric CAD models. And of course, those parametric CAD models then need to be actually manufactured in the real world to create the thruster. So let me get into each of those steps in a little more detail and tools that we are specifically developing to support Yavin. The first one I want to talk about is our mathematics toolkit. Advanced projects like Yavin require a great deal of upfront mathematical analysis in order to design, size, and predict the performance of the project. As open source hardware developers, it's essential that we document those analyses that we're doing up front to show the fundamental principles, the implementation, and the results for peer review, and to thoroughly document our projects. Mach 30's MTK, the Mathematics Toolkit, allows developers to create this documentation at the same time and more critically in the same environment as they are creating those analyses. We're implementing this in Python as its analysis language with the goal of creating this single versatile tool to support doing your analysis, We're doing that by building in key libraries that engineers need, like things for support for units. No more what units was that. Your math has first-class units in every operation. And support for documentation by integrating Jupyter notebooks from the IPython world with a Python IDE. Probably right now we're looking at Spider. So put that all married together and get a single environment for documentation and math analysis. That second step was parametric CAD. Who's used open source CAD tools? Okay, when I say CAD tools, I mean things I can get engineering drawings out of. So who's done CAD tools that go all the way to engineering drawings? And it's a little smaller crowd, right? When we went looking for open source CAD tools, we actually looked at both open source and proprietary just to understand the full market. When we went looking, we came up with this chart and saw that it's actually very hard to find something that'll do all the things you need. But we actually wound up finding one that was close, and so we contributed to it actively, and this is called CAD Query. It's a Python-based parametric CAD language that is actually inspired by the way jQuery accesses the document object model in browsers. Key factors that favored selecting CAD Query were its ease of use, powerful API, and active development community. Python, because it uses Python, it has another big benefit. It's compatible with our MTK work, which means analyses done in MTK can come right into our CAD models and directly drive parameters for sizing. And finally, we're actively developing Yavin to be 3D printable on home 3D printers so that schools and people at home can actually do their own rocket experiments to understand rocket propulsion better. Here's an example of said part. And we get that geometry right out of CAD Query and then as an STL and take it to our printer and go. The really interesting thing to me here is that beyond just getting the parts out, focusing on manufacturing also as a key part of our processes is giving the Yavin team the opportunity to research, test, and document, there's that big word again, the performance of 3D printed materials, calibration techniques for 3D printers, and finishing steps for 3D printed parts. And of course, all of this material is going onto the Yavin project page. So, in summary, I showed you the cold gas thruster block diagram and told you how Mach 30 is using Yavin to guide the development of CAD Query and MTK and our manufacturing experience. And I opened by sharing one of our guiding principles at Mach 30 for open source hardware development and discussed how we apply that principle to our open source hardware projects even when sufficient tools don't already exist. So, what do you think? You can check out MTK, CAD Query, and the Yavin thruster at the links you see there.